Great. All right, good morning. Today we will go back to Go for today and tomorrow. On the course wiki, if you go to the today's and tomorrow's lectures, you will see there are videos from last year, and those videos are kind of a step-by-step guide which introduces the structs and introduces the interfaces and introduces the parsing of JSON. So I would like you to watch those videos so I don't repeat myself again. So instead of repeating myself, what I thought we do today, we will do something a little bit more advanced. So the lectures which are recorded from last year are very rudimentary, very simple, and they kind of give you the basis. But then anything you do, you have to use this basis. So if we do something a little bit more advanced, we kind of touch on those topics as well. But I can kind of tell you a little bit more of what I haven't covered last year. So how many of you did the tutorial? Entire tutorial? Yeah. Okay. So any questions about the tour? Any things that you need to understand a bit more so far? Go is kind of really simple language. It has little things. So, for example, to kind of work well with slices, yeah, you may need a day or two to sort of get your head a little bit around the slices, because typically, like in C++ or in Java, you have an array, and then that's it. That's kind of what you work with. And here you have a store which stores the array, and you have kind of an interface to observe it, but it's not the array itself. So it's a little bit different concept to like your normal direct access to array. Of course, you have arrays as well. You can work with arrays, but it's much more convenient to use slices. So that's one kind of a little bit awkward concept. Error handling is a big one. We're not gonna cover error handling today. We will do it a little bit tomorrow. So that's another kind of bad one. And then structs and kind of object-oriented programming. It's easy, but you do it a little bit differently than in other languages. So we will cover that. So please watch the videos. It talks about concurrency, and it talks about the struct, and it talks about like decomposing your classes in such a way that you can use the polymorphic methods or polymorphic functions. So we covered polymorphism last time. Who remembers what is polymorphic in the context of Go? Yeah? Yeah?
Like if you have an interface inside interface, then you maybe well, that was inheritance. Okay.
Yeah, so inheritance kind of helps us to have a polymorphic behavior. So inheritance is one mechanism to achieve polymorphism. Another one is interfaces. Another one is duck typing, like for example in Python. So the basic idea is like, let's have a look. So I will. Just give me a second. processing that you don't have to have F for P, F for student, F for person, F for student, and F for teacher. You can have F for whatever the polymorphic type it is, and then on the runtime it will be kind of resolved. Okay, so but if you watch the videos, it kind of goes a little bit more in depth. So what I thought I will do today, I will kind of show you a little bit how I do simple things in Go and how I work. So the first things I do is I don't use the heavy IDE, I use Vim. So Christopher talked a little bit about Vim last week, right? You don't need to master it, but for doing simple things, Vim is pretty good. So if you fire it up, before I fire it up, we have a repository in the course, and there is a small folder called chat, and there is a single, that's wrong. There is a single file called server.go. So you can clone that repository. So I will clone it as well. Where is the? I don't want to download this. Where is the clone button? Good. Yes, that's right. So that's what I need. So I will go projects. So I will clone. I will clone the repo. Yes. Crap, I don't have the. I have to clone this way. So let me do it offline. Yeah, on this machine I don't have the SSH key. So if you have SSH key uploaded to your shell, you can use the SSH clone. Otherwise, I have to use the HTTPS. So now I have it. So if I go to IMT chat, I have the files, right? I should do git remove server because that's a binary file. You should never keep in the repository binary files. I kind of did it last night, so by mistake I checked in a compiled version. So now if I do vim and I say server, I will see some coloring of the source file, but I have no code completion, and the coloring is also not that good. Like, it doesn't highlight the types. So like for example here, it doesn't really highlight the types. It kind of highlights the keywords of the language, but not the type system. Doesn't do much, and I don't have like a Go commands which I can run the code and so on, right? So to do that, I will go to a website called WinBootstrap, and then if you say vim-bootstrap.com, you are on this website, and then you can highlight what languages do you want to support. So I highlighted C, Go, JavaScript, and Rust. You can say Python as well, but for the sake of not doing too much, I just do those 4. And then you generate yourself a file which is called generate.vim. So then if I move downloads, generate.vim, and I put it in my home folder called vimrc, and then run vim. First, I will not open the file, I just run it, and I say plug update. Because I've already run it, it actually, like, it already has all the plugins. I have them all installed. But if you do it for the first time, you will have to wait a little bit to install all the plugins, right? And then you have all the plugins. And then if you say vim server.go, you'll have kind of a little bit richer syntax highlighting, and you have more kind of functionality in the language. And then you have kind of a Go commands, for example, go run. So I can say go run, and then it will actually run the code, right? So what it is, it's a simple server side of the chat, of the network-based server client program, which allows you to connect between two machines or between two processes and communicate via the channel, via the I/O, to send messages, string messages, right? So the idea is that we will write a very simple example of a Go program, which is a command line program, which has a server part and then the client part. And then the server part will open a socket and will wait for the incoming connections. And then the client side will open a connection to the server. And then if you have multiple clients, a client can send a message, and then all the clients will get the message. So it's kind of like a chat server, right? So if you, let me do this. So we will have two parts. One part is the server part, and then we will have a client. And then what the server does, it opens the socket and waits for incoming connections. And the client will open a connection to the server, and the server will maintain a data structure of keeping track of all the incoming connections. So if the client opens a connection, it says, okay, let's say client A, we'll have client A connected. And then if we have client B connected, then it will add client B, and then if one of them sends a message, like hello, in, then the server will broadcast it to all registered clients, right? So the idea is to have a very simple chat server which allows you to connect multiple clients and broadcast the message. If whoever sends something in, it broadcasts it to everybody, right? So that's the idea behind this code. So someone wrote this code, which is this part, which is the part for that thing. And we will go over, I will explain how it was designed and how we're going to change it, right? Because we really need two parts. We need the server part and client part. And we also would like to have some sort of monitoring, because if you have two machines, and on one of the machine you run the client, and on the other machine you run the server is like silent. The server doesn't do anything. And actually the server doesn't store the messages. So if you send it in, the server will broadcast it to everybody, but the server is not the client itself, right? It's not participating in reading or writing the messages, right? But it would be nice if you have only two machines that they can talk with each other, right? So that the server can also send messages in and kind of print messages from the client. So you just need two to play with it. Currently you need three, because you need a server and at least two clients, right? I mean, if you have just one client, if you send it in, it will echo to you because it broadcasts to everybody, right? So you can still test it with just two, but it's a little bit stupid. So let's see how the part responsible for wiring it up. So you have some functions at the top, and then at the bottom you have the main function, which sort of starts everything up. So let's start with that one, right? So the main function opens a kind of a chat room, some form of a data structure that we have, and then it opens the connection to port 6666, right? So this is and by the way, this program doesn't use any external dependencies. It's kind of all built in on what's available in Go. So it uses a network package, and it opens a connection on TCP on this port. And then if this is opened, then there is a listener, and the listener is called if someone wants to contact it. So this method blocks and waits until someone contacts the server. And then if that happens, it returns an error and the connection, right? So error handling in Go is usually not through exceptions, like in Java or in C++. Error handling is by functions returning an error, like in C. So here we have two return parameters for this method, and one is the connection and one is the error. As you can see, we're not doing error handling here. So if we don't want to do anything with a particular variable, we use underscore, right? Which tells the compiler we're not gonna use it. Because if you set here, if you did say, so let's say we call it A, yeah, I mean E. So if I, and if I say go build. So if I try to build it, it says, no, you cannot build it because you declared variable E, but you're not using it, right? So it says build failed. And if I go, where is my, yeah, if I go to this line, it says E is declared but not used. You cannot have variables that you declare but not using. So if I'm not using a variable, I have to use underscore, and then the compiler will not complain. It will ignore that variable that I'm returning here. And then once I have the connection, then I will kind of communicate this connection into a particular channel. So what is a channel? Yeah, so in Go you have kind of a kind of more abstract concept to deal with concurrency. So I kind of explain more in details in the other videos, so I will not kind of go into the details. You will kind of watch it, but the basic idea is that you have kind of pipe-like or queue-like data structure, which you can write on one end and read from the other end. And this you can pass around between different threads, and this you can use to communicate between threads. So if someone wants to read from the empty pipe, it will block. So if you're trying to read from an empty pipe, it will block and wait until something is there. And then if someone tries to write to an empty pipe and nobody is reading, it will also block. So you will try to write, and it will kind of wait until someone wants to read. And then it will kind of synchronize, right? So the reads and writes will kind of be matched internally by the runtime system. So you don't need to synchronize your threads to access some shared variable like you normally do in C or in Java and so on. You basically use a channel, you pass the channel around, and then the synchronization will happen automatically, because if someone is writing and nobody is reading, it will block. If someone is reading and nobody is writing, it will block. But if someone is reading and someone is writing, it will kind of pass the data, right, atomically between the threads. So the idea here is that we have a channel inside the chat room which keeps all our connections to all the clients. So this square which I drew there, like the data structure for keeping all the connections, it's basically this channel here. So we will go into that in a moment. But before we do that, I will decompose the whole thing, because we have this sort of library functions here. We have some data types and some declarations, and we have the main, which is here, right? And that's all good, but we realized that we need two main functions. We need one main function for server and one main function for the client. And they both will probably reuse some data structures. So what we want here is not to have everything in a single file. We want something that has all the types and all the functions that we need in our program, and two executables, one called server and one called client, right? So to do that, normally, come on. So let me don't have. So I'm using Mac, and Midnight Commander is like a very primitive a file system browser. I just want to show you kind of the file system. So while it's doing that, I will show you here. So we have our directory structure, which is basically, we have something called chat. And the chat is kind of our package. And then inside, we have our code, right? And then when we will be using it from outside, we will be using it by saying chat.something, some public functions that we declared, right? So if I have a public function called fun, I will kind of use it like this. And I will have to import chat as a module, right? Everything that has capital start letter in Go is exported as a public thing. And everything that has a small first letter, it's hidden inside the module, right? So chat is a module, and everything that I have with the small letter will be inside, cannot access from outside. But if I did something with the capital letter, it will be visible from outside. So now I need two executables. And the constraint is that inside the chat, so if I go to chat, here I cannot have two executables because only one executable. Okay, so let's roll back. So you have the concept of a package, and the package lives in a particular namespace. So our package will live in the namespace chat, and then executables. If you check the server.go, it doesn't live in a namespace chat. It lives in a namespace main, because executables have to live in a namespace main, right? So that's already kind of a conflict. So if you have a folder for a particular package, you cannot mix two different packages in that folder. That folder needs to be either chat or main, right? And our one is main. So if I have another file here which says I'm in the package chat, the compiler will complain because in the same folder I will have both chat and main. You can only have one of those, right? So in Go, I mean, you can solve it in different ways, but typically what you do is you organize your code in such a way that you have the main library in the main package, like in our case it's chat and the package, and then all the executables you put into a sub package called command, which is CMD. So if I show you again our structure currently, and if I say I have a directory called command, and then in this directory, if I create two files, and I will create a file called server.go and client.go. So now I have, oops, I didn't move, so move client and server to command. So now in the main, right, so the funny thing is I originally have the original code base called server, right? So we have to move the server back. So command server comes back, and we have to rename it. So we say git move server, and we need a different name. Like all the library thing cannot be called server because that's our executable. So we can call it we can call it utils.go. Right, so now I have in the main chat I have utils.go, and I will change utils.go. I will say utils.go is not in the package main, it's in the package chat, right? And I will go exactly. So the main executable will be in the command, right? So I will copy utils into command server.go. And now I will go to command, and I will edit the server. And this one will be in the package main. And I don't need any of that. I only need a main method, right? So I don't need any of the code that I will have in the library. I only need a main method. Right. So now I am inside my main method, and I will need to use my chat, right? So new chat room is a function from the chat module, right? So I have to say chat, and then anything I want to use from the chat module has to start with capital letter, because if this function starts with small letter, I cannot use outside of the package. And then I have to import chat. And then my main method will be here. So that method kind of bootstraps the server, right? In the client, we don't have anything yet. So client is kind of empty. We don't have anything. And then inside util, utils, I'm in the package chat, and I don't have main method here, because you cannot have a main method in something that is not a package main. Yeah, I mean, initially when you think about it, it's a little bit confusing. Like, what the hell? Like, what's going on, right? But once you do it once, it kind of makes sense. But yeah, so that's one thing I haven't covered last time. So, and that was a little bit confusing, right? So let me show you, right? So I have this this directory structure. So I have a folder called chat, and then inside the chat folder, which is my main package. So this chat folder usually lives in the Git repo somewhere. So it will be, you will have, like, for example, github.com/your user ID /something, and that usually that's what it is, right? So usually it will live in the top level of your repository. If you have multiple repos, I mean multiple folders inside your repo, and you want to differentiate them, you can kind of make the hierarchy a little bit, right? So in our case, we're doing hierarchy because the repository name is IMT2681, which is the main repository name, and it has a folder called chat. But as my internal Golang package, I don't want to use the full Git thing. I just want to use chat because it's a kind of internal project. If you want to share it with other people, because of Go conventions, you would have to use the full qualified name. So then inside chat, I have my code, but I don't put main function in my code, in my library here. I put all my main executables inside a sub package, which is called CMD. It can be named anything, but out of convention, a lot of open source Go projects use this convention, right? So it's just a convention. And then inside here, each file, you should only have one file per main function, and each file is your executable. And you should name it, again, by convention, the way you want your executable to be named. So in our case, it would be called client and server. Are those names good? Yeah, not really, because if there is a lot of client or server things for different things, right? So you should have a little bit more qualified name to distinguish that this is about your chat client, right? So maybe it should be called chat, or maybe IMT2681 chat server and chat client, right? So it's distinguished name. So if someone builds it and has this executable, it has a unique name, right? Client and server are not unique enough, but for the sake of the exercise, we don't have to be too creative. So then each of those files will have a main function, and that's the one which actually runs something, right? And then when you're building it, you're building those executables because they will use the internal package, which is this one, yeah? Yeah, so we will get there. So now if I try to build it, so if I will say go, let me make it big. So let's build it. So go build, and then we say command, because I'm already inside chat, and we try to build server, right? Okay, it complains line 3. Yeah, let me see. Yeah, so the error message is not what I expected. I expected kind of the error message you're getting about the import thing, that you cannot import chat. And that is because we didn't tell the compiler that we have the package chat yet, right? And Go is using, yeah, by the way, Go 1.13 came out last week. And we will be using the 1.13 from now on. So you need to upgrade your 1.12 to 1.13. There is not a lot of differences, but the modules work slightly differently, and the error handling works slightly differently, and we will take advantage of those new features, right? So Go modules is something that confuses everybody, but it's still a little bit better to what they have before. Before, they didn't have this concept of Go modules. They had a very complex kind of internal system of managing dependencies. This one is a little bit better, and it kind of works similar way to Java Maven or to yeah, like Node.js kind of a package dependencies. So you basically have like a package repository where you can link all your dependencies from, and Go will kind of download them automatically, and it's linked with Git repositories as well. But I will not go really into details here. I will just tell you that you need to initiate a module, and you do that by saying go mod. Yeah, you can use init or tidy. You need, yeah, let's say, so I told the runtime system to initiate a module in the current folder, right? So now it created a go.mod file, and if I show you what this file is, it basically says, okay, there is a module in the current folder, and we're using Go version 1.12, right? So I will change it. Oops. So I will say, actually, the module is called chat, and I want the, yeah, let's use 12 because I haven't upgraded on this laptop yet. So now if I say go build current folder, it will build it, right? So it kind of builds utils.go, but there is no executable because utils.go doesn't have the main function. So if I say go build command server, we have the same error message which we had before, right? So let's see why we do have that. So it expects a string in this line, right? So I said, you know, import chat, but chat needs to be a string. So we need to make it into a string. And then if we try to build a server, it says chatroom joins is undefined because you cannot refer to unexported field or method joins. So what is it all about? Yeah? Say it again? Exactly. So because joins is a field in the struct, let's have a look. So if I open utils, I have a field. So I have a type called chatrooms, which is a struct. And this chatroom has 4 fields. And all the fields are small letters, which means the chatroom is exported, it's visible outside, but none of the fields which it has is visible outside. And because my main function uses the joins, which is small j, it says, the compiler says, look, I mean, you either want to make it public or you cannot mess up with the internal structure, right? So we already see here that, you know, it's a little bit kind of not nicely designed, right? So you have to ask yourself, should internals of my implementation be visible outside my package, or those are details of my implementation, I should not show them outside my package, right? So it's kind of a design decision. And this design decision is because of the main function, right? So if I go again to command server, I am kind of doing, you know, some internal work inside my main, right? Would it be nice if I kind of have to change, if I change that, and instead of having this for loop here, had something like chat room, I don't know, run or something like this, and pass the listener to that method, and then I don't need with the implementation details of how the chat room handles the connections, right? Would that be nicer? I think that would be nicer, because that hides from outside world how I'm actually implementing my processing, right? In the current implementation, I'm kind of messing up with the internals in the main, right? You could say maybe what we really want is not even mess up with the listener. Maybe all we need is just create a new chat room on a particular port. So I may say, create me a chat room on port 666. And that's it. Maybe in the main, we just want this. And then everything is hidden. Everything is inside the implementation detail, right? But again, you have to ask yourself, do I want a server to have a single chat room on the particular port, or do I want multiple chat rooms on that port, right? So if you want multiple chat rooms which do different things, then the original, I mean, this one is kind of better. Do you feel the difference? I mean, they will all work. I mean, the current code would also work if I change the joins to capital J, right? But that would be a kind of a hack, right? It would be like it would smell. It would feel like at some point I will have to pay a price for like doing kind of little hacks like this, right? Once your application grows to having like 30 files, those little things will kind of compound, and then doing any changes or doing kind of some maintenance will kind of haunt you, right? So even though the application is trivial, you have to think about those little things, how to make them well, so then you don't need to fix them later when your application kind of blows up, grows. So I feel this one is kind of fine because it will hide the way I'm kind of working with the files. So I will kind of delete it from here, right? I will have to have now a new method called run, and it kind of takes a listener type from the package network. So let's do that. So so we'll say utils.go. Yeah, I don't have all my keyboard shortcuts here. Yeah, let's quit it will be a little bit simpler if I use the IntelliJ, because then I can have multiple files, and yeah, I have the keyboard shortcuts there. So what we will do, we will move this a little bit of functionality into the method inside the utils. We will export the method, and then we will kind of go through the method, because now we really need to only export two things. We need to export the new chat room and run. Everything else should not be exported, right? And why don't we want to export everything? Well, for we want to make the packages and the modules kind of as succinct as possible. So because then if you make it public, all the clients will depend on it, and maintenance is harder, right? Because if you change something, you break the compatibility with your clients. But if you're only exporting to methods or to types, maintainability is kind of easy, right? So yeah, so I will import the package, projects, this one and this one. Are you doing anything? Maybe. Yeah. Okay. Yeah, you already see that like working with the big ID is like much slower. You sort of need to wait. With Vim, it was sort of immediate. So okay. Yeah, so the idea is, and also when you're checking the linter, if you're checking all the sources for your library, it will complain at the moment because all the public methods and public types that you have are not commented. And linter kind of expects you to have comments for everything that is public, right? So we will change. Let's see. Editor. Font. Okay. All right, so we have client which is exported, read. I mean, client we need to have exported because we're using that type for as a data structure for, no, actually we're not using at the moment. The only thing which we're using currently is the chat room, right? So this data structure we're using, and then we have a broadcast method, join method, and listen method on the chat room. And then we are using this function, so we need to have a comment here. So we say new chat room. So that's also kind of a convention that you start your comments by repeating what it is that you're commenting. So then when you're looking for something, like with using grep or some of those Unix tools to find some text, and you find this line, it will actually have the type already in the line. So if you print that line, you will kind of have the initial comment and what it is, right? So new chat room, and that kind of creates a new chat room for handling incoming connections. We don't need that. We don't need that. So now this is fine. This is exported. Everything else, we're not really using it at the moment. So all of those could be small letters, right? We're not kind of exporting it. We're using it internally. So I will change those to small letters. The only thing that we're using internally is now the run method, right? So we have a function called and a function called run, which takes a chat room. Yeah, actually, we want it this way. So again, you have two ways of writing those methods. So, and that's the thing that we copy and pasted, right? So chat room is our chat room, and here we need a listener. And we have to specify what type is it. So I can have, so let me do the E is not nil, then we need to handle the error, right? And then joins can be small because we are already inside the package, right? So now we need to find the type for this method. But before we do, what is the difference between func run chat room and listener versus that signature? So what's the difference between me declaring this method as this method or doing it this way? The body is exactly the same, just the signature is different. Yeah? Exactly. So functionally, like in terms of functions, it's kind of the same. Functionality-wise, there is no difference. You can do either way, but you will use them differently, right? So this one is only working with the chatroom structs, actually with the chatroom structs pointers, right? I need a pointer to a chatroom struct, and then I can call a method on that pointer. I cannot just call this function out of the blue, right? So if I have my code, if I say run, A, B, I cannot do that with the second one. I have to have A being a pointer to a chat room, and I can only call it like this, right? Whereas with the first one, I will call it like this. So it kind of depends, right? Typically, if we have functionality which operates on a particular type, on a particular struct, we use the second convention. But what if I want this to be polymorphic? Then you may consider the first convention, right? So it's a little bit subtle, like, but you have a choice. In this particular case, the choice is obvious. You should use the second model, right? Because it kind of makes sense. So now let's find what is the type of our listener. So for that, we will go and we will search for Golang net package. So Golang has kind of like a nice documentation browser online. You can have a local copy, and it basically lists all the structs and all the functions that you have. And what we want to find. It's not the most unique keyword in this. So we need to find a function called listen on the TCP listener, right? So I have a function called accept. So yeah, let's go back to why we're looking for it. So if we go to command server, we see that I have my listener and it calls accept, and we want to see what types accept returns, right? What sort of things it returns back. And we see that accept, let me make it bigger. I lost by making it bigger, I lost where the accept was. Yes, okay, only 6, so it should be better, yeah. So if I go here, I can see that it returns a connection and returns an error. So what is the connection? So the type con is in the package net. So it basically returns net.con with capital C, right? So if I say here that listener is of type net.con, the compiler should be happy as long as I imported the net. Make sense? No. So that's this one. So listener is, let's go back to this accept thing. Accept is done on the pointer of the TCP listener, right? So I'm calling the method accept on the pointer of TCP listener, and the method returns con and error. We don't need, for the method signature, we need the pointer to TCP listener, right? Yeah. So now the listener is of that type. This method returns now the connection. You already know that this declares the variable, so I don't need to specify what type it is, because the compiler will work out what type it is. It will know it's net.con, right? So now another question. Sometimes you're writing those methods yourself. So sometimes you're writing a method which returns a struct, right? Should you return a struct? So again, to recap, the con is of type net.con, right? When should you return the struct, and when should you return, because you have two choices here. You can either return a struct, or con could be a pointer to net.con, right? When it makes more sense to return a pointer, and when it makes more sense to return the actual struct by value. And what's the difference? Yeah?
You can move the stuff around a lot. You have like array and must be point to you that rather than construct.
Yeah.
But I don't think we're going to do that now.
Exactly. So it's again, it's a little bit subtle, right? Typically, you will return the struct if you don't have to move it around too much, and if you're not copying it too much. Then you can just return it by value, right? But if the struct is quite big, if it has a lot of data in it, and it's moved around, then every time you're moving it by value, you actually have to make a copy, right? So to prevent those copies and occupying the memory and to make it a little bit more efficient, you can consider returning the pointer, right? Sometimes you want a struct to be kind of immutable. You don't want things to be messing up with it. So then you don't really want to let somebody have the pointer to it, because then they can mess up with it. But if you make a copy, they can only mess up with the copy, but they cannot touch the original. So then you want to pass by value, right? In this case, the API is returning connection by value, which probably means they don't want you to have access to the actual connection. So you don't want to mess up with the internals of what they don't want you to see, right? So maybe they have some pointers inside, or I don't know, like, I don't know why sometimes those decisions are whatever they are, but you will notice that in API, sometimes you're working with pointers and sometimes you're working with the passing by value. In C++, it's the same. Like in C++, you can return structs or particular types by value or by pointer, right? And you're always asking, okay, should that be a pointer? Or should I just don't care and just pass by value? And the rule of thumb is start with passing by value, and if that consumes a lot of memory or if it's slow, then start messing up with pointers, right? Most of the time, the compiler will kind of make your life easy if you kind of just passing things by value. It's a little bit easier with the move semantics and with the allocation and deallocation of memory. It's a little bit similar here as well. All right, so now we have the run method. We have it kind of encapsulated. So if we go back, so if I save this and I need to change, unfortunately, I didn't change. So I quit my Vim before we modify that, right? So we need to use chat. We don't need to use net, hopefully, and we want to make this chat room dot run, and we were passing listener and whoops, chat room, yep, and we don't do that, and we're not handling errors here. So again, we have to handle errors. So we say if we have an error, I don't know, we print it. So let's save it. Say it again. Yeah, that's right. So you probably should return, right? In this case, we should not be calling run if we can't have the handle to the listener, right? So we say we have an error and we just quit. So let's try go build command server. Yeah, okay, so because I changed the the implementation names into small letters, but I didn't change it in the code, right? What we should do is we should do it differently. So we should, yeah, this is all fine. So I should highlight it, and then in the IDE I should say refactor, rename, and then change it to small letters, right? So if I do this, it will change it here, but also everywhere I use it, right? I will not do it for the other ones. I just try it for this one. So format we haven't imported in the server. Which one I need? Yes, I do need net as well. Okay, so let's try that. One error. So I have line 17, which is using net listener as type net TCP listener. So that's fine, which means I can be broader. I don't need to be so specific of what the listener is. So I can do as they suggest, and look here, this one is actually a struct, not the pointer, right? So if I do that, whoops, it compiled my server, right? So now if I look here, I have an executable which I built. So let's try it. And it's a Mac executable, 64 bits, and it kind of successfully built it, right? So if I run it, it will it should ask me whether I want to open a port 66666, and then it kind of runs, right? It doesn't say anything, so it's a little bit like we don't see any diagnostics, and we cannot pass a port, right? So what we will do is we will kind of modify it slightly to be able to pass a port myself from the command line, and to have a little bit of an extra output saying, are you really running, right? So before we do that, nice thing about Go is that it has a multi-platform support built in. So for example, if you have C++ Hello World program and you want to compile it for Mac, you basically have to get a Mac, right? But if you have Go, and I have Go here, and I want to compile it for Linux and give my executable, like to deploy it on a Linux server, all I need to do, I have to say Go operating system is Linux, and Go build command server, and now it builds it again, but this time around, when it finishes, I will have a Linux executable, and I can do the same for Windows, right? Yeah, the first time you're doing it, it needs kind of to get all the runtime system for Linux. So now if we check it, you see the file sizes are different. So if I check what file is that, it will say, look, it's a ELF Linux 64-bit executable. It's not Mac anymore. And if I try to run it on Mac, it will say, no, it's not executable on Mac, right? I can do the same. I can do the same for Windows. So I can build my command server for Windows, and then I will get a server.exe executable, and it's you can run it on Windows. You can also compile it for 64 bits, for 32 bits. You can compile it for ARM. So now we have a Windows executable as well, right? So I have a Linux and Windows executables. You can compile it for Android. So you can generate an Android executable on ARM as well. So it's pretty straightforward to do a cross compilation for a different platform. All right, so what we want is we want a little bit of information that it's actually running. So what we will do is we will print here server accepting connections, and yeah, we should handle the error. So what should we do if there is an error here? Should we quit? Say it again? Yeah, that's correct. So we will print that we have an error. We'll print what the error was, but we can kind of we should not yeah, so we should not do this, right? So I can do this, right? Will that achieve what we need? It will, right? So if there is no error, we will do this. If there is an error, we will not do this. I'm not a big fan of if-else statements because they kind of especially if the if part is long or if the else part is long, you're kind of losing context. You don't know really what is happening when, right? So a little bit cleaner, even though in this case is as clean as, like, both cases are kind of the same. A little bit cleaner here is to say continue, right? So I basically have this as my error handling, and then just normal operation, right? Logically, it kind of is easier to work with code like this than with if-else statements, because you have to keep in your head what you elsing to, what was the else for, right? Here I don't need to care about whatever, because I logically okay, if there is an error, I need to do this. If there is no error, we're just doing the normal flow, and it doesn't matter how long this method is now, because I don't need to remember any if-else kind of context, right? I only need to remember it here. So it makes kind of code a little bit more tidy if you do this way. So continue breaks out of the iteration of the for loop and goes back to here, right? It's like break in C++, I think. Huh? Continue is the same, right? Yeah, exactly. So continue goes back here. So in C++ and in Go, it's the same. So it kind of rolls back to here and starts another iteration. For loops in Go, they are kind of the same as in C++ and C, but they have three forms. You can have the infinite while loop. So basically this one is like while true, right? This is an equivalent to while true loop. And then you have the one which you have declaration of of a variable, and then the condition, and then what to do, right? So the typical one, or you can skip some of those steps. So you can skip the last step. You can skip the condition if you don't want to have a condition, or you can skip the initialization. So you can have just a condition. So if x is bigger than 10, right? And because that would look stupid, you're skipping the first part and the last part, then you can write it basically like this, which is then equivalent to like a while loop, right? So Go has syntax like for all types of looping, but it just has a single keyword for. So for this, in this case, is an infinite loop. So our program still is a little bit smelly because here we have no way of finishing the run, right? I mean, I'm kind of an infinite loop, and there is no way for me to shut down nicely the program because I cannot quit out of this loop, right? We can leave it as a kind of an exercise for adding a check if we should finish iterating the loop and quit, right? And then you can have a channel which informs the chat room that we basically roping down, we shutting down, and then you should stop listening to connections. To do that, if accept, like let's have a look to the accept method. So you can see that accept awaits for the next call and returns a connection, right? So it's a blocking call. So what does it mean is, even if we have here a check, so for example, if we add a check, well, let's do the check at the beginning, right? Add a check to quit the loop if program shutdowns, and let's nicely do to do. Okay, so now we have a to-do item. We know we need to fix it, but we go into the loop, we check, are we shutting down? No. So we execute the next line, and that one blocks forever because we want to shut down at some point, but we kind of waiting at that line, right? So our idea of like shutting down sort of is a little bit broken because this one is a blocking call. So we would need to find a non-blocking check if there is something incoming. If there is, we call this, we kind of consume the connection and do the logic. But if there isn't, we go back. So what is this called? Like if we're doing that. So let's say this one is, let's imagine that this one is non-blocking. So we're checking, okay, is there a connection? If there isn't, we kind of skip, right? So we kind of doing the loop like this. How is this technique called? Probably has many names, but let's say it's called busy waiting. So you have a loop which chews up 100% of your CPU and you're doing nothing. You're basically waiting for something to happen, right? So it's like, let's say you wrote a I/O controller for games and you're waiting for a user to press a button. And it's like, oh, did the user press the button? No, not yet. It's like 100% CPU, right? And then the user presses the button and then you trigger something, right? So what's the advantage of busy waiting apart from burning a lot of electricity and warming up your house? The computer is doing nothing, but you know the CPU is 100%, yeah? Exactly. So the biggest benefit is that it responds immediately. It's the fastest response you can have, right? But if you're not happy with the burning of the electricity, so we need to do another one, which is change accept into non-blocking variant. And then once we have the non-blocking variant, right, so then what we can do is we can, in this loop, we can add a bit of a sleep. So instead of looping like as fast as possible, we kind of do the iteration, there is no connection, and then we sleep for 100 milliseconds or 200 milliseconds, and then we loop back again, right? So what it means is we will be looping, but we will be not looping as fast as possible. We will be looping with a little bit of a delay. So you have so you have a busy waiting can be solved by just adding a little bit of a delay. The benefit is that it's very simple fix. You just add one line sleep for 200 milliseconds, and instead of like looping 100% of the CPU is used like 2%, right? Because you kind of every 200 milliseconds or whatever you kind of check, but you're still checking. So it's not ideal, right? What's the ideal solution for instead of doing busy waiting? What can you do? Yeah, so in this particular case, it's a little bit tricky because we already have kind of the notification here. Like we will be notified if something is kind of available, right? So we do have the notification mechanism here. It's just that we don't want to block on this notification mechanism. So kind of you can think what, yeah. You can have a thread which sleeps until you have a particular event happening, right? So you may spawn something which kind of waits, but then again you need something to kind of shut it down when you don't want it. You don't want to wait anymore. So there is a solution. It's just a little bit more complex. You need to build a little bit of an extra machinery to kind of use it. But it's the ideal solution. So the ideal solution is that something kind of waits for being notified that the connection is available. It reacts when it's available. So no CPU usage in the time when you're waiting, like no resource waste, but your code becomes a little bit more complex, right? So let's say write more code. But then you have kind of a perfect solution, right? All right, so we fixed that. So let's do the final thing. The final thing was we wanted it to have in the main, in our server, we don't really like this here, right? We don't like the inability to come on, work. That we cannot change the port. So ideally, what we would like to have is we would like to have an integer, which is our port, and this way we can yeah, so we need to change it to string. Yeah, let's, if we kind of cheat, we can say it's a string, right? So huh? Yeah, that's right. So let's do that. And then we need kind of a way of parsing the command line arguments, right? So let's Google that. So let's say Golang command line parsing. So there is a package called flag, and this package is basically doing exactly what we need. So we declare what kind of parameters the command line arguments will have. So in this case, we kind of declaring that we will have an integer called flag name, which has a default value, and then some kind of a help message. And then we kind of assign the value to this from the command line to this variable, right? So if I do that, oh, come on, yeah, just let's type. So instead of doing that, I will say we have a port, which is flag. So we could do a number, but then we have to convert it to a string and so on. So let's, like, just for the simplicity, let's use a string. We just need to check so it's a name, value, and then the usage. So we'll say string port to listen on, and then default value will be 666 if we don't provide it. Yeah, so that's actually the comment port. And we need the flag. And we need to say flag parse. So let's see if this works. Remove server and server.exe. Go build command server. Say that again. 59. Yeah, the error is in the utils. So we need format. Yeah, so the thing is we can't mix var and declarations, so we need to get rid of this. Right, so now we have again mismatch type because we have to dereference the port. So all those functions will return you a pointer to a given type because that's how it works, right? I mean, I cannot return it by value because I would have to do it by value in this line. But by pointer, I can do it when this method happens. So this pointer after this line executes is actually nil. But after this line executes, this pointer becomes a pointer to the string. I mean, if we have a port, right? Or, I mean, it will become a string because we have a default value. So I have to dereference it. So now we have ability to parse. And then if I say server port equals 777, then I will be kind of accepting connections on different ports. If I don't say it, it will accept connections on 666. It would be nice if we kind of print what port we are listening here, right? So let's go just do a small modification to our utils. And that was line somewhere here. Accepting connections on port. And then we need to get a port, right? So listener. Well, we need to check how can we get a port number from the listener port. So Yeah, because we're kind of running out of time, I will leave it for tomorrow. So the idea here is that we extract from the listener, we extract the port and print it here. So then we sort of know if the parsing of the command line kind of worked. The idea here was that it's very easy to add command line parameters and kind of work with them. And you have, if I say server help, you have the help message for free as well. I didn't code it, it's part of the flag package, and it tells you, okay, you can use server, and you can say port string, and then, you know, what is the default and how to use it, right? So you can easily add your command line arguments to your programs. So I will commit this, what we have done today, into the Git repository, and we will kind of wrap it up tomorrow. But watch the videos from the previous class about the usage of interfaces and the usage of structs and pointers to structs. It will kind of help with this lecture which we had today. So thank you.